Hello everyone. This is a little math problem that I posted on Facebook recently after I spotted it on somebody else's feed. And I was quite intrigued at the number of answers that I received. This covers, I think, pretty much the extent of it, and as you can see, they're all over the map. And if you're thinking, well, there's probably just one right answer and the rest are wrong, it actually, to some extent, depends on how you interpret the various different symbols, and it turns out that there are actually 4 of these that are genuinely correct, although I would argue that there is one answer which is best, and that is 333. So let's walk through it. As you can see, we have 3 rows and that lead into a 4th row, and with each of the 3 initial rows we're supposed to learn something about various different symbols and then apply what we've learned to that last row to deduce the final answer. The first row has a bunch of clocks, and in this case we're saying 3 clocks added together equals 21. So it's probably a reasonable assumption to say that a clock equals 7. And there's really nothing wrong with that assumption. It's a bit generalized, but strictly speaking, a clock could be equal to 7, regardless of what time it's showing. So if you were to work forwards from that point, you would get one of the right answers. But I would suggest that you look a little bit closer at these clocks, and you'll discover that the times in the clocks happen to match up to 9 o'clock, 9 o'clock, and 3 o'clock. And when you add those all together, you get 21. And because this does reflect what's in the puzzle and is a bit more specific and an interesting coincidence, I think it's probably a safe guess to assume that the value of the clock is equal to the value of the time shown on the clock. Let's go on to our next line. Here we have calculators. Every single one of these calculators is identical, and when we add them all together, we get 30. Therefore, we could make the same generalized assumption that we made on the last one and simply assume that each calculator equals 10. But what if there's something more specific, like there was in the prior line? Well, if we take the digits that are shown in each of these calculators, 1 plus 2 plus 3 plus 4, it happens to add up to 10. So again, we have something that's a bit more specific that still makes sense within the construct of this particular line. So we're going to go with the assumption that the calculator's value is equal to the sum of the digits shown on the calculator. That brings us to the third line. Here are the light bulbs. And in this case, you'll notice that we have 15 plus 15 minus 15 equals 15. Many people made the mistake of not seeing that minus sign, assumed it was going to be another 3 things added together. So that certainly would have been an incorrect answer, but if you notice the minus sign, really what it means is that the second and third bulbs cancel each other out. So it's just one bulb equals 15. But are we sure about this? Is this good enough for this particular answer? Is there something more specific that we can use to make this worthwhile? Well, if we take a look at the bulb as represented on this line and the bulbs as they are represented on the next line, are these equivalent? Well, here we have 1, 2, 3, 4, 5 light rays, and in each of these bulbs we have 1, 2, 3, 4 light rays. Therefore, certainly we could say that 5 rays does not equal 4 rays. So let's say that a bulb with 5 rays is equal to 15. Therefore, 1 ray is equal to 3. 15 divided by 5, of course, is 3. So what have we learned so far? Our first row told us that the clock will show a time, and the time is the value that we want to use. On the next row, we had calculators, and in this case, the sum of the digits shown in the calculator was equal to the value. And then on the third row, we had light bulbs, and in this case, we deduced that the ray was equal to 3. And that brings us to our last row here, where we have to figure out everything. We start with a clock showing 9 o'clock. We're now going to add a calculator, And in this case, isn't this interesting? We don't have 1 plus 2 plus 3 plus 4. It's 1 plus 2 plus 2 plus 4. So definitely the digits showing in the calculator were significant. So in this case, 1 plus 2 plus 2 plus 4 equals 9. Then we have multiplication here that we had to watch out for. I think some people didn't spot the multiplication sign. And then we have bulbs. In this case, we have 3 bulbs times 4 rays per bulb, and we know that 1 ray equals 3, which means we now have times 36. So we have to figure out what is this answer. Now, this is where many other people made a mistake. In arithmetic, there is an important thing called the order of operations, and there's an acronym that many people learn called BEDMAS. And BEDMAS says for arithmetic operations, brackets comes first. Well, it doesn't matter whether the square brackets, curly brackets, rounded brackets. Exponentiation comes next, like 32 squared, the square root of 25. Then division and multiplication after that. Doesn't matter which order you do division and multiplication as long as they are the next step. And then finally, addition and subtraction. So what that means is in our case, we have 9 plus 9 times 36. The first step has to be the 9 times 36. Which brings us to 9 plus 324, and finally 333. So I hope that clarified the best way to solve this particular problem. As I mentioned, there are at least 4 correct answers from what I can see, but this is most definitely the most specific answer that is also correct, and I would suggest that this is the best answer. Hope you enjoyed this little demonstration of the power of math. Just pay attention to all those little details and have fun with it. Have yourselves a good evening, day, morning, whatever it happens to be. Bye-bye.